Moving on into the how to automate DCA with Alana Pi, I want to first add that Python is an open source language, so we are going to use a lot of the tools that it can give us. In this case, we are going to start by importing the fundamental libraries. This is, for example, the automated DCA workflow. This will be uploaded into the documentation section of this module. We're going to start by importing. Later on, or in previous sessions, we saw how to provide an authentication to use the Alana Pi. So on. This has been covered several times before. So I'm going to first start by selecting some wells. In this case, let's remember that the API gives us several functions. In this case, I'm going to, in the last session, we uploaded the Loma Campana field of Argentina into the Alana server. So I'm going to, in this case, I'm going to create a dictionary. I'm going to create a dictionary for these field masters. Now we are going to, in this case, I'm going to create a string which has the field that I want to work with. In this case, we're going to create a scenario. As Alejandro showed, we're going to create a scenario, and we're going to add several wells to that scenario, and we're going to automate that the DCA analysis to those specific wells. Okay, so I'm going to create, in this case, if we, for example, we create a data frame that has all the well masters using the MyAPI get well master function, we are going to be able to have all the wells that are contained on the server, right? In this case, you can see that this is the wells that we uploaded in previous sessions, and that we have several information such as latitude, longitude, comments type, spot date, production date, and so on and so forth. In this case, this is not like a session of Python, introduction of Python, but I'm going to create a list that has all the well names of the particular field that I want. In this case, the Loma Campana field. So using this statement, I'm creating the list well names field that has only the well names of the Loma Campana field. If I check for the how much wells are in that field, well, that's quite a big number, 840 wells. So I'm not going to work with all those wells, but in this case, if we use Python tools in order to visualize, to select the wells, I'm going to import an additional library. In this case, I'm going to use a library called Folium, which is an open source tool for plotting in a map, kind of in a map environment. So if you go and download this library Folium, in this case, I've already installed it, so that's why it says requirements already satisfied. I'm going to create a little function that will plot, in this case, a data frame that I provide to the function, and it will plot using the latitude and the longitude. Okay, I'm going to create, I've already created a DF data frame with all the wells, right? And I've just created in this next line a list of all the well names. So I'm going to create, in this case, a data frame that has only the wells of this field. In this case, I am going to use these two commands that will create df wells field. It will create a data frame with only the well names of this field. So I'm going to click and I've already created a function that will plot, but I'm going to kind of guide you through it for the sake of this learning experience. So I created this function map wells volume, which will require the data frame. In this case, I know that the data frame will be either the whole field or maybe the whole well master or either the data frame that I require. In this case,
can you show the data frame?
Yes. Okay, I'm going to show you the wells field data frame for you guys to see it. As you can see here, we have the 840 rows, which correspond with the wells of the field, and the columns, the 13 columns that comes from the get well master function of the Alana Py script, and that has the information that we previously covered, right? So I'm going to feed this function with this df. I'm going to then, in this case, inside this function, I'm going to create several lists. In this case, the latitudes, the longitudes, and the well names. For what? Because we need an X, Y point and a hover point. In this case, the hover will be the well name. I used this single row kind of iteration process to create a list. And in order to create a map in Folium, you can provide the function volume map. We can provide for a location of a point, which will be the center point of the map. And of course, we can as well add a start zoom or a zoom start, how to visualize or how much to visualize in the map that we will create. In this case, the map center will be the average of the latitudes and the longitudes. Just this is a simple summation process of lists. In this case, the map center is a list of these 2 points, the average of latitude and longitude. The map zoom will be in this case 10, and I'm going to give Folium all the markers or all the points in this case of the wells that will be plotted in the map. And in this case, I'm going to return the map, the object created from folium.map. Okay, so I'm going just to execute this. I'm just going to execute this function. There you go. We didn't have any issues with that. If we run it and we provide with the give me yes. I didn't import properly Folium. Import Folium. There you go. That was the issue. Okay, so I'm going to provide this data frame of all the wells in the field to this function. And we are going to get, in this case, the Folium map or the Folium object with all the wells in this field. So as you can see, this is the location of the wells of the Argentina field. Yes. But these are all the 840 wells. Okay, this is open source. You can install the Folium, you can use it, you can check the GitHub, you can provide and keep updating and keep posting updates to that, the beautiful of open source, right? So anyway, if we hover, we can check that it will print the name of the well. But I mean, I want to select several wells. I can't. I can check, or we can do 800 automated DCAs, but for the sake of the session, I want to create maybe 50 or 40 wells. So I need I need to make this much little. So I will go through several properties that I have in the Alana script and the Alana Pi script, and you know, the information that I that I possess in the domain expertise of a petroleum engineer. So I'm going to run this, and for example, in Loma Campana we have as well. We have several types. We have either production, exploration, or appraisal. In this case, we lower the amount a bit. We have 850 wells in production, so that kind of doesn't get us to the places that I want. So I know that we have in the Alana table for the well master, we have as well the formation. So if we check for the formation in the whole in the well master, we have the Huygens formation, the both formation. We created synthetically in previous session a formation A and formation B, and we have from the Argentinian data all these formations. So I'm going to select just I'm going to run another command in order to get the formations in the field Loma Campana and the total amount of wells in that formation. In this case, we have that the Vaca Muerta formation has 675 wells. So that gives us much more little amount of wells in which I'm going to select. In this case, I'm going to select the Vaca Muerta field, the Vaca Muerta formation. I'm going to create another string and store it. And in this case, I'm going to filter the using this this characteristic. I'm only going to check for the wells that are on the on this formation. So if we create a DF data frame well filter, I just did that, and if we check it, we have the yes, of course. In this case, in this last line, I said, you know what? I want to create. I want to select the first. In this case, let's see, 50. I'm going to create a data frame with only the first 50 rows of this Vaca Muerta formation of wells.
25.
Okay, 25. 25. Excellent. So if we check it, we have 25 elements here. Let me run that again. DF well filtered. There you go. 25 elements, as you can see. Okay, so if we the practicality of Python gives us the tool to do this. I'm going to plot only these 25 wells in this Vaca Muerta field using the function that we created, and there you go. We have 20 wells in this whole field of Argentina. In this case, this is going to be one well, this is going to be another well, and so on and so forth.